examples that we will do in this lesson. Here's the first example. Solve for x by completing the square. So we have a quadratic equation. The first step by completing the square is we're going to move that constant to the right side. So we're going to undo the minus 16 by adding 16 to both sides. So we're left with x squared plus 6, and I'm going to purposely leave a little bit of room after that 6x, and that equals 0 plus 16 is 16. Now here's the part of completing the square. We are going to take half of this middle term. Half of 6 is 3. Then we're going to square that number. So 3 squared is 9. Now we're going to balance out the equation by adding 9 to both sides. That's why I left the room on the right of 6x. If you do one thing to one side of the equation, you must also do it to the other side. Now we're going to go ahead and factor this left side. If we use our T-chart, which most of you probably aren't doing the T-chart now written down, you're probably doing it in your head. You say, what are the factors of 9 that add to 6? Well, the factors of 9 that add to 6 are 3 and 3. So how you factor this is x plus 3, x plus 3. If we were to FOIL that back out, we would get x squared plus 6x plus 9. Then the right side, 16 plus 9 is 25. Now I'm going to combine the two parentheses together. X plus 3 and x plus 3 is x plus 3 all squared. Now think back to the lesson that we did yesterday, where we solved by undoing. The rest of this problem, to find out what x is to solve by undoing. So we have to undo the x plus 3 all squared. So we're going to square root both sides. Don't forget the plus or minus on the right. So we get plus or minus 5 on the right, because the square root of 25 is 5. On the left, the squared and the square root cancel each other out, and we're just left with the radicand. Now we're going to separate this equation out into two parts. X plus 3, which equals positive 5, and x plus 3, which equals negative 5. And now we solve those for x. So we'll solve by undoing. We're going to minus 3, minus 3. So x equals 2. Then over here, again, minus 3, minus 3. So x equals negative 8. Those are your two answers for x. You can take these two answers if you want and plug them back into the original black equation. They will equal 0. So this is one new way to solve a quadratic equation, by completing the square. Here's a second example. Now that you've seen one of them, this one you might just want to watch and not write down. So we first move that constant to the right. Then we're going to take half of this middle term. Half of 2 is 1. Then we're going to square it. 1 squared is 1. This is what we're going to add to both sides. So plus 1 and plus 1. Now we can factor the left side. So we use the T-chart. What are the factors of 1 that add to 2? Well, they are 1 and 1. The right side is 7 plus 1 is 8. Notice what happened in the last example and this one. They're the same parentheses. That's going to happen every single time when you do completing the square. They're going to be the same parentheses. So you can combine them together as x plus 1 all squared. Now we solve the rest of this problem by undoing. So we're going to undo that squared. So we square root both sides. And then the squared and the square root cancel out. We're left with just the radicand. On the right, we have plus or minus square root of 8. Now we're going to break up this equation into two parts. X plus 1 equals positive square root of 8, and x plus 1 equals negative square root of 8. Now continue solve by undoing, minus 1 to both sides. So x equals negative 1 plus the square root of 8. And then minus 1 to both sides again. X equals negative 1 minus the square root of 8. Now think back to your reducing radicals worksheet. Can you reduce down the square root of 8? Yes. You can rewrite 8 as 4 times 2. And now what pops out is a 2 because the square root of 4 is 2. So our final answer is negative 1 plus 2 square roots of 2. Now we're going to do the same thing on this right equation. Just change that to a negative 2 square roots of 2, where that square root of 8 is. Now look at the answers. They're not whole numbers or integers, they are radicals. Example 3. This one, we've already set up the right side where the 3 is on the right. You can choose if you want to write this example down. I'm going to leave myself some room, and then I'm going to take half of negative 8, which is negative 4. Then, do you remember what you do with that? You square it. Negative 4 times negative 4 is 16. That's what you're going to add to both sides. Now we can factor that trinomial. What are the factors of 16 that add to negative 8? Well, it's negative 4 and 4. So it's x minus 4, x minus 4. What happened again? They're both the same. Now on to the right. 3 plus 16 is 19. Now we finish the problem by undoing. So we're going to square root to undo the squared. Don't forget the plus and minus. Then the squared and the square root will cancel out. So we're left with x minus 4, the radicand, plus or minus the square root of 19. Now we can break up the equation into two parts. X minus 4 equals positive 19, and x minus 4 equals negative square root of 19. And now we just finished by undoing. We'll undo the minus 4, so we'll add 4. So we get x equals 4 plus the square root of 19. And then over here, add 4 again. So x equals 4 minus the square root of 19. And 19 is a prime number. You can't multiply two numbers together besides 1 and 19. So we leave those alone, and those are our two answers for x. It's about 9 minutes right now, so I'm going to stop the recording, and we have one example left.